Okay, the test is going to be on, no, Thursday now. Yep. It's a review today. Yeah, Thursday's the test. That way Friday, if people miss, they can make it up Friday. Monday, Tuesday, we won't start anything new, so you guys will have whatever you want to do next Monday, Tuesday. Okay. So, a lot of you are gone, remember, tomorrow, so this is the review. If you want to watch this on your iTunes U, you can just look over this, what I'm videotaping now for the review, because everything we're doing here will be on the test. On the test, there's only 2 of them you got to sketch. Either a perpendicular bisector, an angle bisector, a median, or an altitude. You're going to have to sketch it yourself. So remember, if you sketch the perpendicular bisectors,
do we get to pick which ones we want to sketch?
no, it tells you either an acute or obtuse or a right triangle. So, if it's acute, or if it's right, or if it's obtuse, they will be a little different. These 2 will always meet in the middle. These 2 will not. So when you sketch them in, remember, you've got to show, when you're doing perpendicular bisectors, you got to estimate where the middle is, and then draw a line that's as close to 90 as you can. Show that it's 90 with the box, because that's worth a point, and show that it's bisected, so you got to put the little marks in there. Then you got to do the other one. Show that it's 90, show it's bisected, and then this one. And then will all 3 intersect in the same spot. If it's an acute triangle, they intersect in the middle. If it's a right triangle, they intersect on. And if it's obtuse, they intersect outside. So remember, draw the 90, show that it's bisected. There's going to be right about up there. And then this one. Okay? So, for perpendicular bisectors, you need to know the name of this point that they intersect. It is the circumcenter. And what the circumcenter is it's equidistant from all 3 vertices. So those distances are the same. There, there, and there are the same. There, there, and there are the same. So you need to know the circumcenter is equidistant from all 3 vertices. The angle bisectors. It really doesn't matter if it's acute, right, or obtuse. They will always intersect inside. But remember, when you're showing the angle bisectors, you draw a line that cuts it about in half as close as you can, and then show that it's bisected. And then on this one, you'd have to put 2 marks there to show they're equal. Then this one, you put 3 marks. So they all intersect in the same spot. This one's a little smaller. Okay, so remember, make the marks on here. Show that sides are bisected and it's 90 here. Show that the angles are bisected here. This point, you need to know the name of that. That is the incenter. Yellow. Yeah. Okay. Yeah. Bye. Connor, your mom. problem, sir.
Bye, Connor.
I told you your mother being a bad boy, Connor.
Okay, I did.
Yeah, tell your mother I said hi now.
This is on my decision.
Tell her.
No, this one's not good.
So the in center is equidistant from all three sides. This one's from the vertices, this one's from the sides. So this, and this, the last worksheet we just did, they'd all be equal. From here to here, here to here, and here to here. There to there, there to there, there to there. Okay? Then on the medians, similar to angle bisectors, they will always meet in the middle. So to show a median goes from the midpoint of one side to the opposite vertex. That's all it does. So the only thing you gotta mark is that this is the midpoint. So then from here to there, and they will also meet at the same side, or at the same spot right there. So on a right triangle, it would go like that. It would go there and there. So remember what that point is called? There's circumcenter, in-center. No. This is the balancing point of a triangle. If you were to cut it out and put your finger on it, you put it on that point to balance. It is the,
Balance.
no, centroid. Again, you need to know that centroid is associated with medians. The thing that this one does now, remember with the centroid, is it cuts each line into two pieces. If this is 8, how long is that one? 4. Remember, the smaller piece is half as much as the longer piece. If this is 6 right here, this piece would be 3. If this was 5 right here, that'd be 2.5. So that's what the centroid does. All right. Then the altitudes. Altitude is just how tall it is. So if it's an acute triangle, you just draw it straight to the other side and it forms a 90. Straight to the other side forms a 90, and they will also intersect at one spot. So the medians only have the midpoints, the altitudes only have the 90s. The perpendicular bisector has medians and 90s. But remember, it doesn't always go through the opposite vertex. So on this one, the altitude of this side is actually the leg itself. The altitude of this one would be that one, and then here would be that altitude. So they intersect right there. On a obtuse, here's one altitude. Now remember what you got to do. If I got to go from this vertex to this side, but it's got to form a 90, so what you got to do is you got to extend it out. That would be how tall it is from this point to that point. So this one you got to extend out. So there. So these, if you continue the altitudes, they would intersect way down here. So this point is called the orthocenter. This one has no mathematical thing that we can use like these other ones. But you do need to know that if they tell you it's an orthocenter, that means they've drawn the altitudes. Okay, So you need to sketch, there's only 2 of them out of these possible ones that you have to sketch. Just remember to label all the stuff. But there are other questions on there, like with this. They tell you something's a centroid, so they tell you this long, you need to find that length. Or they tell you something's an in-center, they tell you this one, you gotta figure out that one. Well, they're all the same. Okay? They tell you it's a circumcenter, they tell you this length, you want to find that length. Well, they're all the same. So, the rest of the test I got up here. This is just a review at the end of the book. We had a problem like this in your assignment. I told you it was going to be on the test. If they tell you that U R is congruent to UT, what can you conclude about point U? Now, if you forgot, back when we went through this, if you bisect any segment, or do the perpendicular bisector, this was the very first thing we did. Any point along this line is equidistant from each endpoint. So since this equals that, what can you conclude about that point?
Or half.
It's so easy, it's hard.
It's the same.
It's the middle of
That lies on the perpendicular bisector.
That means it is on the perpendicular bisector. If something is equidistant from 2 other points, even though the line's not continued on there, that means it is on the perpendicular bisector. That same exact question's on the test. So, if SQ is the perpendicular bisector of RT, that means this is 90, and that means those are equal, right?
Yeah.
Since it's perpendicular bisector. Explain how you know that RQ equals QT. Well, because it's a bisector. And RS equals TS. How do we know that this equals that? Because any point on the perpendicular bisector is equidistant from each endpoint. So I already answered this question. If UR equals UT, what can you conclude about point U? You can conclude it lies on the perpendicular bisector because it's the same distance from each endpoint. So that would be your answer. It lies on the perpendicular bisector. And you do got to put perpendicular because it's not just the bisector. So this last one, if Q is equidistant from SR and ST, SR is this one, so it means that's equal, and ST is this one, so that means that's equal. What can I conclude about that point if it's the same distance from the 2 sides?
They're equal.
Perpendicular bisector.
It's on the what?
Perpendicular bisector.
No.
Okay.
It's equidistant from the side, so you can conclude that it lies on the angle bisector.
So would that make them equal or
Remember, if a point is equidistant from 2 sides,
it's half?
it's on the angle bisector. If it's equidistant from 2 points, it's on the perpendicular bisector. Okay, so here they have the perpendicular bisectors intersect at K. Find KR. How long would this be right there? They drew it in blue, which means this is 12 right here. And if this whole side is 32, what's this? So what we got to do is we got to find this side. Once we find that, this will be the same. Because remember, they're the same distance away.
Oh, yeah, yeah.
So you've got a right triangle where that's 12 and that's 16. What do you do to find the other side? Yep, 12 squared plus 16 squared, and then you square root it. And that's going to turn out to be 20. I believe. Yep. Okay, so since this is 20, this is also 20. So remember the Pythagorean theorem. If you're looking for the hypotenuse, you square them and add them, and then square root. If you are looking for a leg, say it was this, 20, 16, and x, you square them and subtract them, and then square root them. Angle bisectors. We want to find WB. Since it's an angle bisector, this piece and this piece will be the same. And we can figure that out because they have a right triangle right here. So we're going to have to square them both. You either add them or subtract them. Subtract because you're looking for a leg. So remember, when you subtract, you do got to take the bigger one minus the smaller one. And then square root it. You'd get 6, which means WD is also 6. Medians. Since we have the angle bisectors, what is that point called?
Century.
In center.
In center. Angle bisectors is the in center. Here we just have, these are 6 and 6, 7 and 7, 8 and 8, and they're all perpendicular. So what's that point called?
Orthocenter.
So these are all bisected, and they're all perpendicular. It's the circumcenter,
Oh.
Okay.
the perpendicular bisectors. Here, all we've got is the medians. So that is the centroid. And then the last one, they have an altitude, an altitude, an altitude. That's the orthocenter. Okay. So they have an example here, but again, I showed you up there, just to remind you, if this were 6 and they asked for that length, everyone knows what it would be? Hopefully. 3. Remember, the shorter piece is half as long as the longer piece. Now make sure you know what they're asking for. Sometimes they mess it up. ABC. They'll tell you this is 6, and then they'll ask for AC. So AC is the whole length. 9. So then you got to figure out, yeah, that's 3, so the whole length is 9. Then the mid segment. Mid segments are parallel and half as long as the side that it's parallel to. So, if this is 12, how long is this? So then each of these would be 12 because it's cut in half. If this is 9, that means this is 9, so what's this? 9, because the whole thing's 18. If this is 22, this is 11. Okay. Perimeters then, I'll just use this one. If this is 10, this is 20. If this is 9, that would be 9, and this would be 9. If this is 24, this is 12. So remember the inside perimeter, which is what they're looking for. 9, 10, and 22 is 31. Without adding it up quick, what would be the perimeter of triangle PRQ? If the small one's 31, what's the big one? 62. It just doubles. Okay. Then the last part, what we did was the biggest angle to the smallest, or the smallest to the biggest, and the shortest side to the longest side. if they're sides and we had to do the angles from least to greatest, what's the smallest angle here? C. 8's the shortest side, so C is opposite, that would be the smallest. Then 9, so that's A, and then B. When they do the angles, here we'd have to figure it out. 750 is 120, subtracted off of 180, that's 60.
Okay.
So, what's the shortest side?
JG.
JG. Because 50 is smallest, and that's opposite. Then it would be 60, so HG. And then the biggest would be opposite to 70, JH. Those should be simple, huh? And then the very last thing we did was that hinge theorem, where you just gotta put greater than or less than. So here is AB greater than or less than or equal to CB.
It's less than.
It's less because 88 is less than 92. Is angle 1 greater than or equal to or less than angle 2?
Well,
It will be less than.
It would be less than because 15 is less than 16. Is TU greater than, less than, or equal to
Equal.
VS? They're equal because they're both opposite of 126.
Sounds good.
All right?
Do we have an assignment or no?